Relational Database Overview. In this section, let's spend some time looking at what a relational database is and also look at some of the key characteristics of relational databases from the perspective of the architecture, the features, how applications connect to it, connection pool, and so on and so forth. So what are the objectives? In this section, we will look at what a relational database is, we'll define it. We look at the RDBMS server architecture. Then we look at the features of a relational database. We look at various relational databases that are there in the marketplace. And then we'll look at how applications connect to relational databases. Especially we'll look at connection pools. Then we'll look at replication, failover, scalability, and backup in relational database systems. So what is RDBMS? Well, RDBMS stands for Relational Database Management System. It's a data management system that is based upon relational theory, which is based on mathematical theories by COD. In a relational database, you have schema. Schemas have tables. Tables have rows. Rows have columns. And then there are keys in a table. There's also index. There's also a relationship that can exist across different tables and also within a table. So a schema is really a collection of tables, index, and other resources. A table is a collection of rows. A row is a collection of data, which is really columns. The columns are the ones that hold a specific value. A key uniquely identifies a row in a table. An index allows you to search really fast. And rows within the same table or different tables, when they are associated via a key, it forms relationship. And that's one of the key aspects of relational databases, and that's why we have R in RDBMS systems. Well, there are some things called DBMS, which is database management systems, and there are many different kinds of DBMS. There is the hierarchical data management systems, network data management systems, object-oriented data management systems. In this case, we are looking at the relational database management systems. One of the key characteristics of relational database management systems is transactional capability, which we call ACID semantics. A stands for atomic, there's consistent, isolation, durable. This is a topic by itself. You can read a lot about this. I'm not going to get into the details of what ACID semantics means. There's a lot of nice articles out there, nice YouTube videos out there. But the most important thing is it gives you transactional capability. Now let's look at the RDBMS server architecture. Now when you say RDBMS server, it's really usually a machine, and in that machine there is a process that's running. There may be disk associated to that particular machine, or it may be part of that same machine itself, depending upon how the data is brought into the database. But the important thing is that there's a process, which is the actual relational database server service listening on some kind of a port, and then there's the disk. In the disk is where we have the actual data, which is kept in terms of tables and rows and columns and indexes and B trees. There are also log files. Anytime you make changes to a piece of data, logs are maintained. There's also control files that tell you who can have access to what data, who are the different users that can have access to the data. So that's the disk portion of it. Disk is very important when it comes to relational databases, because if you think about what a relational database does, is it's really I/O. It takes a query from the user, goes to the disk, retrieves the data, and gives back to the client, or takes a piece of update and then updates the data on the disk. So it's really I/O operation primarily that it's really doing. So disk plays a very important role. And then there is the process. The process portion is really the processing aspect of it, where it's keeping some data structure in memory. It keeps track of all the different tables, rows, and columns and indices, and the B trees associated with them, metacode, plans, SQL statements. There's a lot to it when it comes to an RDBMS server architecture. That's the actual process portion of it. So that's the process portion of it, which is where all the I/O processing is being done. And then there is the persistence aspect of a relational database. The persistence aspect of it is where the disk comes into play. So that's generally what an RDBMS server looks like. And by the way, when a server is running, we call it an instance. So what are the RDBMS features? Well, there's data safety. data is immune to program crashes. In the olden days, we used to have applications where they would actually keep the data in memory and then write it towards the end. If the program crashes, you lose all the data. But with RDBMS systems, you can write the records immediately to the database so that when the program crashes, you don't have to worry about the data. You can also do concurrent access. You can have multiple applications accessing the same data, the same record, and that's where the asset semantics come into play. It gives you transactional capabilities. There's also fault tolerance. There can be replicated databases. So you write to the master and there's a slave, and if the master crashes, the slave picks it up. So there's the replication aspect of it. There is data integrity. When you create tables, you can say what kind of data will be placed in it. Is it going to be integers? Is it going to be strings? Is it going to be bits? And it'll make sure that the data integrity is there. In other words, you cannot put a string in a field that can only take numbers, or you cannot, or if it's a field that's taking only numbers, you can even give ranges, you can give constraints as to what kind of number you can put in. It can only be positive, or it can be only a range of numbers. So a lot of things that you can do in terms of data integrity so that your data is kept meaningful. There is also scalability. A relational database management system can handle a database where you have 10,000 records. It can also handle a database where you can have 100 million or a billion records. So it can handle small or large quantities of data in a fairly uniform manner. Reporting. Easy to write SQL programs to generate arbitrary reports out of the data that's there versus you keeping the data in a proprietary format in a flat file. I think you all know pretty much why databases are needed, but I just wanted to kind of go through these features. Let's look at the RDBMS databases in the marketplace. We have several databases. Very big commercial player is, of course, Oracle. And then a very big non-commercial open source database is MySQL. There's also other databases, Postgres, which is another open source database, and also Microsoft SQL Server, which is a closed source Microsoft database. So these are the four major database vendors that I can think of, but there are hundreds of databases that are out there. I'm sure you worked on different kinds of databases, but I just wanted to kind of point out a few databases in the marketplace. Okay, so how do you connect to a database? How do applications connect to a database? When you write applications, your applications are typically written in a language. It could be Java or Python or C# or Ruby, and every language has some kind of a library. So for example, I have here a Java application. The Java application is going to use the java.sql library to talk to the database. The java.sql library has all the classes and methods necessary for you to communicate with any database. It's a general purpose library. In the same way, Python has what is called the DB API library. So this is the library for Java, which is the JDBC library for Java, which is in a package called java.sql. So the client applications communicate with the JDBC java.sql package, which then communicates with the database. But then it so happens that every database has its own native protocol. They have their own native protocol. And so when a client is writing an application talking to a database, and the database can be a MySQL database or a Postgres database or a SQL server or an Oracle database, since every database has a native tongue associated with it, you need what is called a driver, which is a translation logic that translates the application library into the native speak of the database. And so whenever you're talking to a database, you typically need this driver, which is really what we call the ODBC driver or the JDBC ODBC driver, which in Java we call the JDBC driver for a specific database. It can be drivers for, and there are drivers in other languages also. So the idea here is that the applications speak to the database through the driver to talk to the database right there. Of course, we have a database, in a machine we have a database, and we have a client application. The application has to talk to the database. Well, when it's going to be talking to the database, it has to talk over TCP/IP. And so there is a concept called endpoint. Endpoint is the place to which the applications connect over the network to communicate with the database. And so the endpoint is really a combination of the IP address and the port number on which the database is listing on. So for example, the IP address of this database could be 128.220.101.100. So I'm going to put some dots over here. That could be the IP address, and the port number on which the database could be listening on is 3306. Maybe it's the MySQL database. And that's what I mean by the IP port combination that makes the endpoint. So endpoint is really the IP plus the port combination. But the problem is the IP address nobody wants to remember, and the IP addresses can change. And you will see later on that with IP address, it's having the application know the IP address directly is not a good idea, because what happens if the machine which has the IP address fails? In such situations, we actually use DNS host name instead of the IP address. So really you can say an endpoint is really the host name which is the DNS host name of the machine plus the IP address, plus the port. That's what makes the endpoint. It can be an IP endpoint also, but it's the host name plus the port that makes it. And the idea there is that the application is going to use the host name and the port to connect to the database. And that's what an endpoint is. Now that we know what an endpoint is, well, let's look at how an application is built. Typically in an application, in a highly scalable application, you have a load balancer. We talked about the load balancer and the various application servers in the previous module. These application servers could be Elastic, Beanstalk, Tomcat application server, or it could be your own custom managed application server. These application servers will be running applications which want to talk to the database. The way they will talk to the database is by using the endpoint, which is the location of the database and the port number on which it's going to be communicating, which would be the host name of the database and the port number. Now, it so happens that when a client communicates with the application, the load balancer will forward the request to one of the application. The application will then connect to the database, retrieve the record, and give the answer back. Well, opening a connection to a database and closing the connection once it's done is a pretty expensive operation. Opening and closing is very expensive. The actual select statement or an update statement may not be as expensive. When I say expensive, it's in terms of time. It may take maybe 50, 60, 70 milliseconds to open a connection to a database and close a connection to a database, when it may only take 10 milliseconds or 20 milliseconds to actually do the operation. So in many application servers, many application developers use what we call a connection pool. A connection pool is really a set of connections that the application server will open up. In this particular case, the application server has a connection pool where we have 1, 2, 3, 4, 5 connections that have been kept open to the database. And so whenever a request comes from the client to the application server will use one of the connections from the pool of connections that's already open, communicate with the database, get the answer back, and return the connection back to the pool. This actually speeds up your application communication time to the database. Now let's look at database replication. Usually you have a master database, and that's where all the data is stored. But many times you may want to have more than one database so that you can do failover, you can do read replicas for availability, and so on and so forth. So let's talk about database replication. Database replication is really synchronizing the database or the data between multiple databases. So we have one master database here, and then we have another slave database over here. And database replication says, let's go ahead and take all the data from the master and update it onto the slave, so the slave has a complete copy of the master. There are two types of replication that are there. There is synchronous replication. Synchronous replication basically says that when the data is written to the master, it will be right at the time of being written to the master, replicated to the slave. Asynchronous replication says that when the data is written to the master, it will be asynchronously replicated to the slave. Let's look at this in a little bit more detail. So here's a client. It's doing an update transaction into the master. When it does the update transaction, As part of that particular update, there will be synchronous update that will be taking place on the slave. Now, all these things are considered to be part of the database. The clients don't really have to do anything. The application does not do anything special. The application simply writes to the master endpoint, but as part of the database, it replicates it to the slave. We'll see how these things work later on when we actually start getting into a very specific database like the MySQL database in combination with AWS RDS service. In synchronous replication, the application writes the record to the master, and then the database automatically replicates everything to the slave. And it does that by using what is called binary logs. So anytime anything is written to the master, logs are written to the slave, which is basically your changes, and then those changes are relayed and updated in the master. So those things are applied into the master. This is another kind of replication, which is what we call synchronous replication. Now, different databases support different kinds of replication. For example, Oracle supports synchronous replication, whereas MySQL supports asynchronous replication. So different databases have different capabilities. But the important thing is whether it's synchronous replication or asynchronous replication, it's a feature of the database, and the client applications don't really have to do anything. Now, what are the benefits of replication? Well, it gives you redundancy and failover. It also gives you performance and scalability. Let's look at that. So let's say that you have clients. These are your client applications. These client applications are application servers that are connected to the database, or they can be standalone clients. So let's say that there are many clients that have connected to the database and everything is hunky-dory, everything is working fine. Suddenly something happens and then the database is on fire. Maybe somebody pulled the plug on the database, maybe the hard disk crashed, maybe the CPU crashed, maybe the network has gone bad. Whatever the reason is, the database is not working anymore. Well, when that happens, slowly the connections between the client and the database are also going to stop working. And eventually it'll get to a point where the clients cannot really do anything, where the client applications cannot really do anything because the database is really not working. Well, in such situations, if we had a master-slave database where the slave database is a standby database, what we can do is that the clients can connect to the slave database. The slave database can be updated from being a slave to a master so it can start taking on all the updates that need to be done. When a database is in a slave mode, it typically does not take any updates. You usually turn that feature off. Now, when you convert the slave to a master or the standby to a master, now it can start taking updates to the database. This allows you to give failover capabilities in a database. And different databases do this in slightly different way. I just wanted to kind of talk about this in a generic perspective. What about performance and scalability? Well, clients are communicating with the database, and as more and more clients start communicating with the database, you'll start noticing that the database is becoming hot, which means the database is performing poorly, which means the clients are not really responding back to the end users in a timely fashion. And so you'll get to a point, if too many connections are coming into a database, your database is going to slow down. It's not going to perform really well. Well, how can a master-slave database with replication help? Well, what we can do in situations where the clients are not able to perform their work is that you can set up the database in such a way that the clients that are performing write operations can talk to the master, versus the clients that are performing read operations can talk to the slave read replicas. So we have a concept of read replicas. And that's what is being shown over here. As you can see, there are clients that are talking to the master for doing write operations, and there are clients or applications that are talking to the slave for doing read operations. Because the replication between the master and the slave, in fact, it actually goes from the master to the slave, that replication is in milliseconds or in seconds. Well, when it comes to replication, when it comes to master-slave, and read replicas, you don't really have to have just one slave to a master. You can have a master and you can have many slaves or slave replicas. And you can even take one of the slave replicas and make it into a master so it can have other slaves from the master. So there are many different kind of combinations that can be done. Different databases support this in different ways. But the point I'm trying to make is you can have pretty complicated tree of master-slave relationships. You have to make sure that you don't get into a cyclic graph, but as long as it's a graph or a tree, you're good to go. What about backup and recovery? Well, many databases give you a mechanism to take snapshots of the database at any instance in time. You can go to the database and say, I want a snapshot, which means whatever the state of the database as it stands at that particular point, that will be copied and stored in some kind of a file so that you can later on recover the database when your database crashes. Of course, when your database crashes, it'll come up. There are times when the database can crash so badly, or if the database data is corrupted, that you may have to recover from the backup. And so backups are taken regularly in database management systems. So in summary, what is RDBMS? It's a relational database management system based upon the relational model by COD. It has schema, tables, rows, columns, index, keys, and of course relations, and that's why it's called the relational database. In terms of RDBMS features, you have data safety, concurrent access, fault tolerance, data integrity, scalability, and reporting. In terms of SQL stands for Structured Query Language. That is the language that is used by clients to communicate with the database, and there are many kinds of SQL statements. There's DDL, which stands for Data Definition Language, that allows you to create tables, index, create users. And then there's also DML, which allows you to update database tables. They are the insert, update, and delete statements. There's also select statements that allow you to query records from the database. And finally, there is DCL, which stands for Data Control Language, that allows you to give permissions. It's primarily used for security. When it comes to applications, applications connect to databases. An application uses drivers to connect to a database. Applications also use connection pools to pre-establish the connections to the database for performance reasons. When it comes to replication, we have a master-slave relationship. Master-slave relationship can be synchronous or asynchronous replication. We can also have master to a slave relationship. When it comes to failover, when the master fails, the slave can be made into a master. And when it comes to performance and scalability, scalability is done by using the master and the slaves for your applications, the master for any writes or updates to the database, and the slaves are used for reads. And by the way, slaves are also called read replicas in many database systems. And then in terms of backup and recovery, as best practice, backup is taken regularly so that you can recover from disaster.